Okay, medians and altitudes of triangles. So let's talk about what a median is. The median of a triangle is a segment connecting a vertex to the midpoint of the opposite side. Okay, so hey, let's draw one of those into this to this picture right here. So if I take a vertex, I could pick any one. I'm choosing that one, and I'm going to connect it to the midpoint of the opposite side. So I'm just going to eyeball the midpoint. Midpoint would be something like that, right? And let's just mark that as congruent, like so. And then if we draw a line segment, hey, this is a median of that triangle. Okay, now there are other medians in this triangle, so hey, let's draw the other ones in. Because I didn't have to choose that corner, I could choose this vertex and connect that to the opposite midpoint. So I'm going to draw the midpoint of this side, something like so. Okay, and should really use a ruler and be more precise here, but that's all right, we're going to get the point. Okay, and then I could draw in one here, which will go to the opposite side, okay? And the midpoint, I don't know, something like this. Now, I didn't measure this out, but if I were to measure this out carefully, all three of those medians would actually meet in the same place. They're all going to be concurrent. So, if you have to make your last line bend a little bit, like it looks like I'm going to have to do, I'm going to do that because I want these three to meet up in the same place. Because if I measured this and was careful, that would always happen with any triangle. All three medians are going to intersect at a single point. They're all concurrent, okay? So that brings us to a new point of concurrency. We already talked about the circumcenter and the incenter. Now we've got the centroid. Well, the centroid is the intersection of the medians. So this is the centroid of this triangle. So this is where the medians intersect. Okay? All right. So, couple things you need to know about medians. The main thing you need to know, other than what it is the relationship between the length of the two parts of the median. Okay, so let's look at this median right here. So I can see, just eyeballing it, that this piece is shorter than this one. This is the longer piece, this is the shorter piece. Okay, so just to make things simple, I came up with a nice name for this piece. I call it the short piece, and then I'm going to call this the long piece. Okay, and each one of these medians is cut into a short piece and a long piece. It always works out like that. Okay, and there's a relationship. So the short piece is going to account for 1/3 of this median, and the long piece is going to account for the other 2/3. So over here, short piece is 1/3 of the median. The long piece is 2/3 of the median. Okay. And if you think about this, just look at this next one, the short piece times 2. Well, if the short piece is 1/3, if you multiplied 1/3 by 2, you get 2/3. So the short piece times 2 is going to be equal to the long piece. Okay, so if you double the short piece, it's the same as the length of the long piece. Okay. And the short piece times 3, well, 1/3 times 3 is 1, so it'd be the whole median. So the short piece times 3 is the median because it's 1/3 of the median, right? And then the short piece plus the long piece, well, that's also the whole median, right? Because it's 1/3 plus 2/3. Okay, so you can think about that in lots of different ways, but thing to remember, it cuts it into 1/3, 2/3 for each one of those, okay? All right, so let's use that piece of info on this next example. Okay, this says Q is the centroid. We have to know that this is the centroid, not just some random point in there. Okay, it's the centroid. Okay, and then we're told that QV is 5. So let's put that in the picture here. QV, that's this segment, is 5. Okay, find RQ. Well, if we look at this, this is the short piece, right? So if I take the short piece and double it, then I'm going to get the long piece, right? Short piece times 2 equals the long piece. So I can say RQ, that's the long piece, is going to be 5 times 2. So 10. So this is 10 units. Okay. Find RV. Well, now if you look at the picture, RV, oh, it's 15, right? 10 plus 5. Or you could have tripled the short piece, right? So that's 15. And then VU over here. Well, since this is a centroid, it's going to connect a vertex to the opposite midpoint. So, hey, VU is going to be 7 then, right? Because I know that that's the midpoint of that side. And there we go. Okay. All right, let's look at this next example. Now we're on an XY coordinate grid. All right. So we've got these 3 points already labeled. Some nice person, it was me, drew the triangle already for you. Okay, so let's follow through these steps. Now, if you look at the last step, E, it says find the centroid. So these are all really just steps to get us to the centroid. So later on we might see a problem that just says find the centroid. Well, you're going to go through this kind of a process. Okay, I just broke it down into sub-questions. It says find the midpoint of FG. Okay, so FG, so I don't know if you can see on the video the grid here, but FG, I'm finding the midpoint here. Now, I could definitely use the midpoint formula, all right? But I can also just see what the midpoint is here, because if I'm looking at this line, it's going through kind of 2 boxes diagonally to get there, and then another 2 boxes. So visually, I can just see that the midpoint is going to be right there, if you can see the grid, okay? So nothing wrong with doing the midpoint formula, but just in the interest of time, I'm just going to visually find the midpoint like that, okay? Graph it and label it A. Okay, there we go. So this was the point 3, 7. And yeah, that's the midpoint of F and G if you work it out like that. All right, so now it says find the slope of AH. AH isn't drawn, so let's draw it. Okay, I'm going to use a straight edge here to try to be a little neater than I usually am. All right, there we go. There's AH. All right, let's find the slope of that. Okay, so this was 3, 7. H is 6, 1. Okay, so here, I'll do the work over here. Oh, and it said find the midpoint on the last problem, so I guess I should put in the coordinates of that midpoint. That was 3, 7. Okay, finding the slope of this line, so let's use the slope formula. I'm going to subtract the y's in the numerator, so 1 minus 7, or you can do 7 minus 1, as long as you subtract in the same direction. And then I'm going to do 6 minus 3 for the x's. Okay, so that gives me negative 6 over 3. That comes out to negative 2. There's the slope of AH. Great. Okay. Now write the equation for AH. Okay, well let's think about what we know here. I know a through point for AH, which is either 3, 7 or 6, 1. You could use either one. Goes through points A and H. And I've got the slope. So if I'm going to need a little more space. So here, I'm going to do my work for C up here. Okay. So what I'm thinking is, let's write an equation in this format. Okay, I know that the slope is negative 2, and I can use either one of the through points. I'm just going to use 3, 7 as my through point. Okay, so I know this is going to be y equals negative 2x plus or minus something. I need to figure out what the something is. So I'll plug in 7 for y. I'm going to plug in negative 2 for the slope. I'm going to plug in 3 for x. That's my x coordinate. And now I should be able to solve this for b. Okay, so I've got 7 equals negative 6 plus b. I'm going to add 6 to both sides. And then b is going to equal 13. Okay, and now I can finally, in here, write my equation because, hey, I know the b and I already knew the m, and I can just plug those two into y equals mx plus b. So y equals negative 2x plus 13. Okay, place point B at the midpoint of GH. Okay, so I'm going to see if I can do this visually, again, just to save time. So you can kind of think of the slope, the rise over the run. So I'm going from 1 to 9. So it's going up 8 to the left 2. So what if I just go up 4 to the left 1? Just did kind of half of the slope. It's really the same slope, but I reduced the fraction. Okay, so yeah, again, midpoint formula would work fine, but here's point B. This is at 5, 5. Just put the coordinates there in case I need it. Okay, and then write the equation of BF. Okay, so we're in luck here because this is pretty easy to write the equation of. I don't really have to go through these steps here because I've got a horizontal line here. Okay, well, it's a segment, but just imagine it that it continues into a line. It's a horizontal line, and it's 5 units above the x-axis. So think of the points on here. I've got 2, 5, 3, 5, 4, 5, 5, 5. All of those have a y-coordinate of 5. So horizontal lines are going to be y equals something or other. This is y equals 5. Okay. All right. Now find the centroid. Well, hey, I forgot to put that's the midpoint there of that side. I found the equation of 2 of the medians. Okay. Now I could find the third one, but if I did the first 2 correctly, the third one should meet in the same place. So I'm looking for this, the coordinates of that. Okay. And if you did this neatly, you can probably see that this is going to be at 4, 5. But let's say you don't have a neat graph. You weren't using a straight edge, or maybe you were just sketching this whole XY axis on a piece of paper. Okay? Well, we could still use the equations of the 2 lines. Okay? So I had the equation. I can use these 2 equations together. All right? I can do a system of equations. So I've got 2 things that are equal to y, so those 2 things are going to be equal to each other. I can use substitution here. I can say, well, if those things are both equal to y, then they're equal to each other. So that means negative 2x plus 13 equals 5. I can subtract 13 from both sides and then divide by negative 2. I'm not showing all my work because I'm running out of paper here. Okay, and then I know my x coordinate here is going to be 4. Okay, and I can see that the y, well, it says y is 5. I already knew y was 5. Any point on this line, the y coordinate is 5. But if it wasn't a horizontal line, you could use substitution or elimination substitution to find the y. Okay? All right, so there's centroids where the medians meet. Okay, we've got one more point of concurrency on the next page. All right. The altitude is the same as the height, which hopefully you already know that, but there it is, just in case. Okay. All right, and an altitude is going to be the distance, but it's the shortest possible distance, which really means it's the perpendicular distance. So this is going to be the perpendicular distance from a side, any side, to the opposite vertex. Okay, so, let's say I want this to go to this vertex. Okay, well that means the altitude here would have to go to the opposite side at a right angle. Okay, so this would be my altitude or height. Okay, and then the base is the side that the the altitude connects to, and it doesn't have to be the bottom. Some people think the base always has to be on the bottom. No, it doesn't. It's just the side that's perpendicular to the altitude. Okay. Let's say on this next triangle, this was the vertex that I wanted to use. So if I try to go to the opposite side at a right angle, I can't really do it and stay inside the triangle. So sometimes altitudes will be outside of a triangle. What you have to think about on this one, I'm trying to connect to this side, and it's not really long enough to go down at a right angle, so I'm going to extend that. Think of this as a table, and extend the table, and you want to go straight down to the table from that point up there. So in this case, here's my height, and my base is still this little piece over there. It's not the whole thing, it's that piece. Okay? And then sometimes, let's say I'm using this again, and this would be my base then, right? And hey, I can't go inside the triangle, but it's not going to be outside either because this goes down already at a right angle. So sometimes the altitude will be one of the actual sides. Okay? All right. And then our last point of concurrency, I promise it's the last one, is called the orthocenter. And this is the intersection of the altitudes of a triangle. You guessed it. That's why I was talking about altitudes. Okay. All right. So let's find the, ultimately we're going to be finding the orthocenter on this problem. And again, I've kind of broken it down into subproblems. Okay. So find the equation of the altitude through point Y. Well, here's point Y. So if I sketched in that altitude, it would go straight down to the opposite side. And that one's pretty easy because this is a horizontal line. So that means this altitude is a vertical line. Okay. And then the equation for that, a vertical line is always going to have an equation x equals something. So this one is going to be x equals -2 because this is 2 units to the left, the y-axis. Okay. All right. Find the equation of the altitude through x. All right. This is going to take some more work. So I want to go to the opposite side. I don't really want to sketch it in yet because I don't know exactly what angle to go at. I don't want to just eyeball it right now because I want to get it accurate. Okay. So what I want to do is I want to think, well, what's the slope of this side? Get a different pen here. What's the slope of this side? Well, if you look at it, it's going down one to the right one, down one to the right one, down one to the right one. So it's going to have a slope of -1. Okay, so I want to think, well, what's the opposite reciprocal of that? What would a line perpendicular to this be? It would be +1. Think of it as -1/1. Reciprocal, just flip it upside down and still be 1/1, and the opposite is positive. So I want a line that has a slope of +1, because I wanted it to be perpendicular to that, and goes through this point. So I'm just going to use a slope of 1. So I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. I'll just keep more dots the better. Keep my line straighter. Okay. And then I've got myself a beautiful altitude. I know that's a right angle, and it also goes through point X. All right. Oh, and we're supposed to find the equation of that. Okay. All right. So I could, use one of the through points. I've got actually a bunch of them, and the slope to write the equation. But let me use a little shortcut here because I'm thinking y equals mx plus b. Okay. I already know that the slope is 1, so it's going to be y equals x plus or minus something. So let's find the y-intercept. All I have to do is think, well, where would this line cross the y-axis? Well, it'd be right there, right? Because I'm going up 1 to the right 1. So my y-intercept is going to be 4. Okay, and that just worked out nicely, but you could always write an equation the old-fashioned way. So there is my y-intercept. Find the coordinates of the orthocenter. Well, it's the point. And I could draw in the third altitude, but I only need 2 of them because they all should meet in the same place. I can see this is going to be the point -2, 2. Okay, so I can see that, but you might get problems where it's a fraction or decimal. You can't see it. You could always use these 2 equations and do substitution or elimination. So I can hey, the x coordinate's going to be -2. Well, it is, right? And if I wanted the y coordinate, I could just plug in -2 for x. I could substitute -2 in for x into the second equation. And there we go. Whoop, that's not my final answer. Sorry. Y equals 2. I already knew x equaled -2. And there we go. Okay. All right. So there's a lot of information that we've accumulated now, because now we have 4 different points of concurrency. So actually let's go over this quickly. So we've got 4 different points of concurrency. Okay. The perpendicular bisectors, where those meet, this is the circumcenter. That was the first one I covered. Okay. The angle bisectors meet at the incenter. So these two were both from the last section from 6.2. Okay. And then today the medians met at the centroid. And the altitudes meet at the orthocenter. Okay, and I've got little pictures of each of those here. Okay, and I'll fill out the rest of this in a second. Now there's a lot to remember there. Got a little mnemonic device here that can help you remember what meets where. Okay, and here it goes. All of my children are bringing in peanut butter cookies. All of my children are bringing in peanut butter cookies. If you can remember that phrase, that can help you. All of altitudes orthocenter. Okay. My children, medians centroid. Okay. Now, the problem with this is that there's 2 different C's, so you still have to remember the difference between those 2. But if you can get that, then the rest of this works nicely. Are bringing in angle bisectors in center. Okay. Peanut butter cookies. Perpendicular bisectors circumcenter. So when I chant this, I kind of break it up like that. So it also kind of helps that you say all of my children are bringing in peanut butter cookies, because then you get them kind of separated nicely. Okay, just a little way to memorize what meets where. Okay, and now what do we need to know about these? The most important thing, the circumcenter is going to be equidistant from the vertices. Okay, circumcenter, here it is, equidistant from the vertices. Well, that's already marked in this picture, right? That those 3 spokes are all congruent, okay? The incenter is going to be equidistant from the sides. And that is also illustrated here. It means that these 3 spokes are the congruent ones, because that would be the distance to each one of those sides, right? It's a perpendicular distance, the shortest possible distance. Okay? The centroid is the one that has the short piece and the long piece, okay? So if this is my centroid, then this would be my long bit, which is going to be 2/3. And this is the short piece, which would make up 1/3 of the centroid. So that's the main thing you need to know about centroids. Okay, and then the orthocenter, I don't know what you need to know other than that that's where the altitudes meet. So we're not really going to work with any of the properties of an orthocenter for now. Okay, that's it for today. See you next time.